In this video, I'm going to look at the slope-intercept form, and in doing so, I'm going to still look at the point-slope form that we talked about in the previous video. So let's recall that if we have point-slope, remember that's y minus y1 equals m times x minus x1. And for our slope-intercept form, that is y equals mx plus b. So if you notice in each one of these here, m is the slope, and over here where we have x1 and y1, that is representing any point on the line. Okay, so here x1, y1 could certainly be any point on the line. Now over here in slope-intercept form, y equals mx plus b, b is a specific point on the line where it is the y-intercept. Okay, so in other words, here B is telling us where the where the graph crosses the y-axis. So in other words, that means that our x-coordinate has to be 0, where the y-coordinate is the value of b. Okay, so I want to look at some examples of where we can use the slope-intercept form. And you can actually choose either one of these to use. In most cases, a lot of students like to use the slope-intercept form only. Other students like to use the point-slope form in other situations. So let's look at a couple examples, and you can kind of decide which form that you prefer to use. So the first example I have, if I give you the slope of a line happens to be a -3, and a point on the line is a -1, 4. We want to find the equation of the line that goes through this point with the given slope. So first of all, I'm going to use the the point slope form. So that means we would have y minus y1. So here we have x1, y1. So y minus y1, so that's y minus 4 equals our slope -3 times x minus x1. So be careful, this is minus a -1. Okay, then if we have y minus 4 equals -3, x minus a -1 is really x plus 1. And there we have our equation. And once again, this here is point slope form. Okay. If we continue the solve for y minus 4 equals, distribute the -3, so we get a -3x minus 3, and solve for y, so move the 4 over, so we're going to add 4, so we get a -3x. -3 plus 4 would be plus 1, and here we end up with our slope-intercept form. -3x plus 1. And once again, we can notice that here we have, this is our slope, -3, -3, and -3. Now, I want to look at how we could have looked at this exact same problem, whereas instead of using the point slope, I want to start out using the slope-intercept form. So I just want to strictly use y equals mx plus b. Now, I'm sure you're thinking, well, how can we use this form because we don't know b, because remember, b here is representing the y-intercept. And up here, we have the point -1, 4, and this is not a y-intercept because our x value is a number. If this was a y-intercept, then x would have to be 0. Well, we can actually plug in here, since -1, 4 is our x and y value, we can simply plug that in for x and y. So if we plug 4 in for y, we have 4 equals the slope, -3, times our x, which is -1. And then all we're left with is the b value, the y-intercept. So now we can solve for b. So we get 4 equals -3, -1 is a +3, plus b. and move the 3 over. So we're going to subtract 3. So 4 minus 3 is 1. So now this here is our y-intercept. So that tells us then that we have the point 0, 1. And again, we know that x is 0 because it's the y-intercept. So now we can use the y-intercept here, and we can use our slope, and we're going to come up with y equals our slope, -3, so it's mx plus b plus 1. So there we have the equation of our line, and it's the exact same thing we found over here. So even though with this example we were given the point -1, 4 and the slope -3, realize that here we could simply use the point slope form to find the equation, or we can use the slope intercept. All right, I'm going to look at one more example, and I'm going to go through both methods again. So for example, let's say that we have m equals a -2/5, and our point this time is 0, -7. All right, now, once again, I'm going to start off with using the point slope. So y minus y1 equals m times x minus x1. So y minus, here we have x1, y1. So that's y minus a -7 equals our slope of -2/5 times x minus x1, which is 0. So we get y minus a -7, so that's y plus 7 equals, distribute the -2/5, and we simply have a -2/5 x. And there's the equation for point slope. And once again, if we continue to solve for y, then we get y equals a -2/5 x, subtract the 7 over, so that becomes a -7. And here we end up with our slope-intercept form. Now, hopefully you realize that if we have a slope of a -2/5 and we have the point 0, -7, I hope that you would realize that we actually have a specific point here. 0, -7 happens to be the y-intercept. Now, once again, how do I know that? Well, your x value is 0. So, if we want to use y equals mx plus b, this is going to be very straightforward because we already know that this is our b value, the -7. b is equal to a -7. So we have y equals our slope, which is a -2/5 times x plus b, so that's -7. And again, it matches the same equation we found using the point slope. So if you're given the y-intercept, then slope-intercept form is much easier and much faster to find the equation. Okay. All right, now I want to see if you can figure out this next example that I have. In this next example, I'm going to give you 2 points, 4, 3, and -4, -4. Now, from the 2 points I give you, I want you to find the equation of the line. And if you think you know how, you can stop the video and see if you can come up with the equation of this line. Now, the first thing we know that if we're trying to find the equation of a line, there's 2 things we have to know. And if we go back up here, and it doesn't matter which one that we're using, whether we're looking at using point slope or slope intercept, the 2 pieces of information we need to know to find the equation of a line, we need to know the slope of the line, and we need to know a point on the line. Now, the point can be the y-intercept, or it could be any point, but we have to know at least one point on the line, and we have to know the slope. So, given this problem, we have 2 points. So we're in good shape, we have a point, okay? Now, that means we need to know the slope of the line. Well, how do we find the slope of the line? Well, if we're given 2 points, we can find the slope of the line by using y2 minus y1 over x2 minus x1. So to find the slope here, then, we would plug in, and if it helps you, I'm going to label this x1, y1, x2, y2, and we would have -4 minus 3. And then we would have x2, which is also a negative 4, minus 4. And if we simplify this, then negative 4 minus 3, we end up with negative 7. And negative 4 minus 4 would be a negative 8. And remember, the two negatives make it positive, so we end up with 7/8. So we have a positive slope. So one thing we already know about this line is that the line is going to be going uphill in this direction because we have a positive slope. Okay. Now, if we want to use the slope-intercept form to find the equation, then that means we're looking at using y equals mx plus b. Now, we could pick any point that we want. We don't have the y-intercept, so that means we're going to have to plug in for y, m, and x. Now, I could use 4 and 3, or I could use negative 4 and negative 4 for the x and y. Now, just for convenience here, I'm going to just use the first point, 4 and 3. So I'm going to plug 3 in for y. So we get 3 equals our slope, which is a 7/8. X is 4, so that's 7/8 times 4 plus b. So then we would have 3 equals 7/8 times 4. So that's going to equal 7/2. Okay, plus b. And then we're going to subtract 7/2. So then we would have 3 minus 7/2. Okay, and that's going to give us a negative 1/2. Now, if b is a negative 1/2 and the slope is 7/8, then we know the equation of our line would be y equals 7/8 x. So that's y equals mx, so 7/8 x plus b, which is a negative 1/2. So there we have the equation of the line. Now, you could certainly go back and we could use the point slope, and I'm not going to go through this one. I think a lot of times people prefer the slope-intercept, but if you want to use point slope, you could certainly do that. And again, you could use either point up here. You're going to use the slope of 7/8, and you could use 4 and 3, or you could use negative 4 and negative 4. So I'll go ahead and set this up. We could take y minus 3 equals our slope of 7/8 times x minus 4. And there's the equation of the line in point slope form. And if you solve that for y, you would still get the same 7/8 x minus 1/2. All right, I want to show you another advantage here of knowing this y equals mx plus b. This can be very helpful in finding the slope in the y-intercept. For example, if I happen to give you the equation x plus y plus 10 equals 0. If you have the equation of this line and you want to find the slope and you want to find the y-intercept, well, if we solve this equation for y, so all we're going to do is simply solve the equation for y. So that means we need to get rid of the x. So we're going to subtract x. So we would have then y plus 10 equals negative x. And if we get rid of the 10, we're going to subtract 10. So y equals negative x minus 10. And if you look, this is y equals mx plus b. So that tells us that our slope, well, is just a negative x, so that would be a negative 1. That's the coefficient of the x, so that's negative 1. And our b is equal to a negative 10. So that gives us the point 0, negative 10. That is our y-intercept. So if you can write your equation in slope-intercept form, which you're simply just solving the equation for y, then you can quickly identify the slope and the y-intercept. Now, one advantage of doing that is if we happen to know the y-intercept, then we know a point on the line. So therefore, this y-intercept is negative 10, so we could go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we go down to negative 10, Okay, and if we know the slope is -1, well, if the slope is -1, then that means that it's understood to be over 1, so that means your change in y is a -1, so that means if we were to go down 1 and then to the right 1, we would find another point. And if we do that, we would then have our line. We could simply connect the points together and we would have the graph for this equation. So that's another quick way that you can graph, excuse me, that's a quick way that you can graph the equation of a line by simply knowing the slope and a point. All right, let's try one more example. What if I gave you the equation, let's say, x plus 5 equals 0. All right, now I want you to find the slope and the y-intercept. Well, once again here, if you notice, you only have one variable. So if we solve for that variable, we get x equals a -5. Well, we're not able to really put this in y equals mx plus b, the slope-intercept form, because we don't have a y variable. But we looked at this earlier in a previous video that if we just have this one variable, then x is always going to be -5. And if x is always a -5, then the graph is going to be at -5, and you will have, whoops, wrong way, that's our y. Our x is a -5. We would be over here on the x-axis at -5, and our graph is simply going to be a vertical line. And do you recall what is the slope of any vertical line? Well, remember, it is undefined. And what about the y-intercept? Well, this graph will never cross the y-axis, so for the y-intercept, there would simply be none. There are no y-intercepts. All right, so one last example here. What do you think is going to happen if I give you an equation where we just simply have the variable y, such as y minus 3 equals 0? Well, once again, if you just have one variable, you can solve the equation for the variable, and we would have y equals 3. And if we were to look at the graph of y equals 3, then that means our y is always going to be 3, no matter what your x value is. So you're going to have a horizontal line. And the y-intercept is easy to find because it's simply 3. That's where it crosses the y-axis. But if we want to identify the slope, then we know the slope of any horizontal line is equal to 0. All right, so make sure you go back and review and make sure you understand here the connection of this slope-intercept form, y equals mx plus b, and point slope. And notice that if you're ever trying to find the equation of a line, you can use either one of these, but you have to know the slope and at least one point on the line. Okay. Also, using the slope-intercept form, if you're given an equation, we can write that equation in slope-intercept form by simply solving for y, and we can identify the slope and the y-intercept, and then we could easily use that to help us graph the equation as well.